Hi all, welcome to Kothayat channel. In this video, we are going to develop a machine learning model to predict the future sales of a Big Mart store. First, let's understand how this machine learning model is going to help the Big Mart management in the real world. When we predict the future sales of a store, so the management will get to know the future so that they can plan the things way ahead. For suppose, if a particular product demand is high in future, so that they can maintain the good amount of stock of that particular product in the stores. If the sales of a particular store is increasing in the near future, so the management will maintain the enough employees to meet those sales. Suppose if the sales are declining in foreseeable future, so that the management plan cutting the employees or maybe they shut down the stores and vice versa can happen. So with the nearest future sales estimations, company's management will be taking the decisions. Now we understand the usage of this machine learning model in the real time. Let's decode the process of creating the sales estimation machine learning model. Step 1, data. So we have the sales data of the Big Mart stores. So once we have the data, we need to understand the data and we need to understand what are the input data sets and what are the output data sets. And once we understand the data, we'll be doing the pre-processing of the data and we'll be checking if there are any null values and if there is any missing values, and we are going to deal with those values as well. And once the pre-processing of the data gets completed, we are going to do the analysis on that particular data. So once the pre-processing of the data and analysis of the data gets completed, we are going to split the data set into two parts. First part is called as a training dataset, another one is called as a test dataset. Ideally, we will be using the 80% of the dataset as a training dataset and rest of the 20% of the dataset as a test dataset. So once the dataset parts gets completed, we are going to create a model. Here we are going to create the gradient boosting regression machine learning model. This model will construct the trees based upon the importance of the input features to achieve the output data points. So once we create the model, we are going to train that model with the training dataset. So once our model gets trained, we are going to predict the values with the test dataset. And after predicting the values with the model, we are going to evaluate the model performance with the R2 score. Now let's dive into the coding. For this tutorial, I'm going to use the Google Colab, and here I have created a new Python notebook which is Big Mart sales prediction machine learning model. Okay, and here we need the data set of the Big Mart sales, right? So here I'm going to the folders and here I'm coming back and content, and here uploading the data set. Okay, and here is the Big Mart sales. Here I'm uploading it. It is showing a warning message: ensure that your files are saved elsewhere. Thus runtime files will be deleted when this runtime is terminated. Okay, so once this runtime gets completed, once this session gets closed in the Google Colab, so the files will be automatically deleted. Okay, I'm going to refresh it. I'm not able to see it. Let me re-upload it again. Upload Big Mart sales. Yeah, here it is uploaded. Now I'm starting the coding. Here I'm going to install the Python libraries which are required for this particular tutorial. Okay, pip install. First one is pandas for the data frames, and the next one is matplotlib, and another one is cborn. So this matplotlib and cborn for the data visualization, and the next one is scikit-learn, and next one is XGBoost. Okay, next one is XGBoost. Okay, for the machine learning model. Just pressing enter, and these Python libraries are getting installed. Okay, and it says couple of pandas is already installed, matplotlib is already installed, scikit-learn is already installed. So all these libraries are already installed. Okay, scaling that, I'm just deleting this particular row, and here I'm starting. Okay, let's read the data set. Okay, first step is reading the input data set. Okay, import pandas as PD. Okay, this is the first step, and here data is equals to PD dot read CSV of Big Mart underscore sales. What we are doing here is we are importing the pandas Python library as PD, and here we are using that PD option here. And the next step is read CSV. We are going to read this CSV file content into the by using the pandas, and we are loading it into a data variable. Okay, here I am printing the data. First, let's print the first 5 lines of dataset. Okay, the command we have to use data.head. Okay, it will print the first 5 lines from the dataset. Okay, here is the dataset. I think we don't need it. Let me close this one. Okay, first column is item identifier, so it is which is a unique column for that particular item. And next one is item weight, so weight of that particular item in the kilograms. Okay, and the next one is item fat content, so what is the content level in that particular item. Okay, here it is, some options are there: low fat, regular and low fat. Okay, and next one is item visibility, this item visibility in that particular store. Okay, when it compared to the all the other items in that particular store. Okay, and then next one is item type, whether particular item is dairy or soft drinks or meat, fruits and vegetables, household or anything. Okay, it will give you the item types. Okay, and here if you see the item identifier also, it is FD in the sense food, and DR says here drinks, and NC means non-consumable. Okay, that is how the even item identifier first 2 characters says the item type details. Okay, and next one is MRP, maximum retail price of that particular item. Okay, and here it is outlet in the sense that particular store unique identification number, which is okay. And the next one is outlet establishment, here when that particular store has been established. Okay, and the next one is outlet size, whether that particular store is a medium, high, or whatever it is, small. Okay, and the next one is the outlet location type, where that particular store is residing, whether it is residing in tier 1 or tier 2 and tier 3 sites, tier 3 cities. Okay, and the next one is the outlet type, whether it is a supermarket type 1 or type 2 or maybe grocery store. Okay, and the next one is the final output column, which is the that particular item in the sales in that particular store. Okay, item outlet sales. Okay, and so these are the columns. So total we have 1 2 3 4 5 6 7 8 9 10 11 12 columns are there. So these 12 columns are there. Here the last 12th column is the output column, so remaining 11 columns will become, first 11 columns will become the input data set. Okay, now we have read the data set from the CSV file into the pandas data frame. Okay, now the next step is, what we are going to do is, we have to see these data types of these columns. So how we are going to see the data type of those columns is, press the data and info. This will give this information about this particular pandas data set. Okay, if you see here, it is having 8523 rows. Okay, 8523 data points are there. Okay, and these are the columns, total index starting from 0 and ending with 11, so total 12 columns are there. And here is the non-null columns, so non-null in the sense where the data is available. Okay, and if you see here, item identifier is having 8523 data points, and it is a non-null. Okay, and if you see here, it is an object data, object in the sense it is a categorical column. Okay, wherever the data type is object, that means that is a categorical column. If you see here, item identifier is a categorical column. Okay, and if you see the item weight, which is a float, which is nothing but a numerical field. Okay, item weight, the weight in kilograms. Okay, so similarly 1 2 3 4 5, so out of 12, 5 out of 12 columns are the numeric columns, and 7 out of 12 columns are the categorical columns. Now we got this information, right? Now next thing is, if you see here, item weight column is having some null values. If you see here, item weight column has the null values, it seems. So out of 8523 data points, it is having only 7060 data points as non-null. So remaining values might be null values. So we are going to check those columns. Okay, whether those are null data points or not. Okay, for data dot is null dot sum. Okay, if you see here, for the remaining all the columns it is coming 0, but only for the item weight and the outlet size, these columns are having null values. So item weight is having 1463 data points as the null values, and outlet size is having 2410 data points as the null values, and item weight is like in a numerical column. And what is the next one? Outlet size. Okay, outlet size, okay, medium, high. Okay, which is a categorical column. If you see here, one numerical column is having null values and one categorical column is having the null values. So how we are going to deal with this? So The first point is whether we can remove these null points. Wherever these null data points are there in the data set, we can remove those data points and then we can go ahead. That is a step one. And step two is here we are going to fill those missing values with the some other values. Okay, here we have the two different types of the columns. One is a numerical column, which is item weight, and another one is a category column, which is the outlet size. Okay, always numerical column. Okay, columns values will be replaced with the mean values. Okay, and for the categorical columns we are going to replace it with the mode. Okay, so what is mean by mean? Mean is nothing but the average of that particular column. Okay, we are going to replace this 1463 data points wherever the null values are there for the item weight rows. We are going to replace that with the average value of that particular column. Okay, that is what we are going to do with the numerical columns. And what we are going to do with the categorical columns is we are going to replace it with the mode. So what is the mode method is? Mode is nothing but the most repeated value. So whatever the most repeated value in that particular column is coming up, then that is what we are going to replace it with the null values. Wherever null values are there for these 2410 data points, we are going to replace it with the that particular column most repeated values. Okay, now let's start with the numerical column, which is the item weight. Okay, I'm just copying this item weight, and first we have to find out the mean value. Okay, mean of data of item weight. Okay, item weight dot mean value. Okay, this is going to give us the mean value of that particular average value of the item weight column. Okay, so if you see here, if you see here, it is coming 12.85. So this 12.85 kilograms is the average weight of the item weight column. Okay, 12.85 kilograms is the mean value, average value of the item weight column. So that is what we are going to replace it with this for the 1463 data points. Okay, let's replace data of item weight and fill NA. Fill NA in the sense data is not wherever not available, that is what the columns fill NA, not available values. We are going to fill with the this value data item dot mean value. Okay, and in place is equals to true. So what exactly this in place does is, so this in place we apply the whatever this operation that we are performing on the data set itself. Okay, just did it. Now let me copy this command and paste it here. Now it should show the zero null records for the item weight column. See here, so item weight column has been replaced, is having zero null values. So whatever the data points which are having 1463 earlier having the null values, we have replaced them with the mean value here. Now the next thing is mode, outlet size. Okay, for the categorical column, what we are going to do, we are going to replace it with the mode. Mode is nothing but the most repeated value. Okay, let's replace that. Data outlet size underscore mode is equals to data dot pivot table. So we are constructing a pivot table here with the values of, for which column it is, outlet size. Okay, outlet size, and next one is columns is equals to, and here I'm going to use the outlet type. Okay, so why I'm using the outlet type here is, if you see here in the data set, okay, let me drag it to right. If you see here the outlet size medium height, which is most relevant to this particular outlet type column. Okay, so outlet size column data is mostly related to the correlated with the outlet type of the column. Here if you see here, outlet size column values are correlated with the outlet type. Okay, if you see here it is medium, that means supermarket type 1, and if it is high, it is a supermarket type 1, medium supermarket type 2. So this is the next column which we are able to find out, okay, what would be the suitable value for the outlet size based upon the outlet type. So that is what we are doing. Okay, wherever the outlet size values is coming as XYZ, and what would be the value of the outlet type. Okay, that is what we are doing here. Then we are going to do the aggregate function is equals to, here we are going to write the lambda function, lambda x colon x dot mode. Okay, let's run it out. Yeah, here I am missing a comma. Okay, lambda, okay, spelling is wrong. Okay, fine. Now let's print this value, outlet size what it is printing. If you see here, this is the outlet size and this is the outlet type column values. So wherever grocery store it is, then it means outlet size is small. Wherever it is supermarket type 1, the most repeated value is small for the outlet size. Wherever the outlet type is supermarket type 2, the outlet size is medium. And wherever supermarket type 3 is, it is medium. So these are the values, the most repeated values of the outlet size based upon the outlet type column. Okay, now let's replace this outlet size wherever it is null values. We are going to replace it with these values. Okay, based upon the outlet type. Okay, now the next step what we have to do is, for the numerical columns we can directly use the fill NA column. Okay, but we cannot be able to use the fill NA for the categorical columns. So here we are going to find out the location of the missing values. Okay, missing values location. How I am going to find out the missing values location is data of outlet size. Okay, dot is null. Okay, here I am going to create another variable where it is going to find out the location where the values are null values. If you see here, I mentioned is null. Okay, is null false in the sense this particular row entry is having a value for that. It is having a some value. It is not a non-null value. And if you see the row number 4, that means row index 3. If you see here, it is true. That means at this particular data point, the outlet size column is having the null value. Okay. So wherever the value is false, that means that particular value is existing for the outlet size column. Wherever it is true, that particular value is null values. So wherever true, we are going to apply this logic, this mode logic. Okay. Now let's write the code for that. Okay. Data dot location of, okay, LOC in the sense location. Here we have been taken this location, comma, and column. What is the column here? Item, sorry, outlet size. Outlet size. Okay. Outlet size is equals to what we are going to do? Data dot location of missing value. Missing values location, comma, here we are going to use the outlet type. Okay, outlet type dot apply. What we are going to apply here is lambda x colon this variable outlet size mode of x. Okay, mode of x. Okay, now we should be good. Perhaps you forgot a comma where it is missing. Again, I'm just typing wrong for the lambda. Okay, spelling mistake. So now it has been replaced. Now let's check it out. Let's print this statement. Yeah, copying and pasting it here. See, we don't have null values for the outlet size. So what we had done is, we have wherever this location is true for this particular outlet size column, we are replacing that with the wherever that location, we are identifying that particular row for the outlet size, and we are replacing it with the outlet size of mod of x. Wherever the value is coming most frequently, we are updating with that. Okay, that is what we are doing here. So once this data fill up is completed for the missing values. Now we have to see the describe, okay, for the numerical fields. Data describe, and data describe gives us the insights about the data only for the numerical fields, not for the categorical fields. Okay, here it is suggesting charts as well. I think they have added new functionalities to the Google Colab, so where we can see the possible values, charts and everything. Okay, just deleting it, and I'm going to retype it. Okay, not 0. Okay, see here, 1 2 3 4 5. So these 5 are the numerical columns. So this is the count, so number of data points 8523, that is common for all, and mean value, this is the average value of that particular column, and standard deviation for that particular column, and here is the minimum value of that particular column, and here is the last one is the maximum column, and again 25th percentile, 50th percentile and 75th 15th percentile. So what exactly this 25% is? The item weight, okay, for 9.3%, or the values are less than the 25% of the values are having the 9.3 as an average weight. Similar for the 50th percentile and similar for the 75th percentile as well. So once this percentile data describe gets to it, let's draw some charts with the C1 to understand the how this data has been distributed for that particular column. Okay, for that one, let's try a data distribution for item weight column. Okay, plot we haven't imported, right? Let's import those. Okay, sorry, my bad. Cool. Okay, let's move on to here. Okay, now let's import matplotlib and c1. Okay, matplot library dot pyplot as plot, and import cborn as sn as SNS. Okay, we have imported the matplotlib and cborn just to draw the graphs and charts. Okay, here I'm going to draw the data distribution for the one of the numerical field. Okay, what I'm going to do here is plot dot figure of, so we are going to draw a figure, and we have to define the figure size. Okay, fig size is equals to x-axis 6 and y-axis as 6, and cborn SNS dot displot. Okay, we are going to use distributed plot of, for which column? Item weight. Okay, data of item weight. Now plot dot show. Okay, now let's try it. If you see here, and the data, so if you see here in the middle for 12.5 against the whatever the average value which was coming for the item weight, the more number of records are for the 12.5, and remaining values from 0 to 5 having less values, and after 20 it is having less values, and 12.5 values, whatever the average value which is coming for this item weight column is, right, there we have the more number of values. Okay, that is what it is telling us, the distributed graph for the item weight column. Now let's draw for the other columns as well. Okay, and here pick up the item visibility column. Okay, item visibility. Now let's draw this distributed plot. It's showing some warning. This plot is deprecated, will be removed. Okay, we have to use the dist plot. Okay, I'm going to use dist plot instead of dist. Okay, if you see here, and the values are between 0 to 1.15. okay, the values are skewed to the left side, and whatever the values after 0.20 are having less values. Okay, this is how this item visibility has been distributed. Now, okay, let's draw for the other column, which is MRP, maximum retail price. Okay, let's try it. The prices of this are in dollars, right? I think after $20, $20 to $25 to, and remain $270. So data has been distributed here, and even if you see here, there are ups and downs. $50 are distributed properly, and then again it came down in the 60 or 70. Again it went up to till 110, 120, and then again it made a drop, and again it moved to the 130, 140, and again it came around down to 200. and somewhat increased around 200 and 250, then it started declining. Okay, that is what for the MRPS. Okay. Now let's draw for the other column, which is, I'll skip the establishment here. I'm going to draw the item outlet sales. Okay, let's draw it for the item outlet sales. Yeah, if you see the sales are good at least till 4,000 sales are distributed to the left side, and after 4,000 I think sales are very less. Okay, or only for the few stores. Now we have drawn this data distribution for the numerical fields. Now let's draw for the outlet establishment here. Okay, here what I'm going to do is, here outlet establishment here is for the year of where that when that particular store has been established, right? So instead of doing the distributed plot, I'm going to draw the count plot here. Okay, count plot of x is equals to this column and data is equals to data. Let's see the count plot here, not the data distribution. Okay, count plot for the year. Okay, not outlet sales, it should be establishment year. Okay, then just copy paste it as it is. It was wrong. Let me cancel it. Okay, this is correct. Yeah, if you see here the sales, if you see here, there are huge number of sales in 1985. Then after 1987 to 2009, the sales are distributed evenly, and except they could see a drop in the 1998. Okay, so this is what we can draw the count plots and the distributed plots for the numerical fields. Now let's draw for the categorical fields. Okay, data dot head, let's print out here, and let's do the count plot for the categorical columns. Let's do it. So the reason why we are doing is, when we are doing a data science project, you need to understand the data. So what kind of columns are there and how the data is distributed inside of that column. Okay, what are the unique values? If there is a categorical column, you will be able to find what are the unique columns are available in that particular categorical column. And if it is a numeric column, you can see that how the data has been distributed. Suppose if you see here that item weight has been distributed like mainly for the 12.5. So we can get this kind of insights from this data distribution or data count plots. Okay, and item identifier, let's try it. I think which is distributed evenly, right? For every what do you call it? Every particular item is having an identifier. I think this is a wrong thing to draw. So let me cancel this one. We don't need for the item identifier, which is unique for each and every item, right? Now I'm just moving on to the item fat content. Okay, let's draw for item fat content. If you see here, low fat, regular, low fat in lowercase, and LF and regular. If you see here, you will be able to identify the different columns. Low fat is 1, and if you see this values has been distributed, and if you see here, the data is not correct here. If you see low fat in camel case letter and low fat in lower case letter and LF, just LF, all these three values are single value, which is low fat, and another one is regular. If you see here, it is regular and here it is REG. So here we have to do the replacement of this low fat LF with the actual low fat with the camel case and REG with the regular. So these kind of insights we'll be getting from this drawing these charts. Okay, and let's draw for the other one, which is item type. Okay, let's try it. Oh, I think data is huge. Columns are messed up. Let's increase the size to 25. Will that work? Yeah, I think if you see dairy, soft drinks, meat, fruits and vegetables, household, baking soda, baking goods, snacks, foods, frozen, breakfast, and all these values are here. Okay, it is kind of ups and downs. That's fine. Okay, now soft drinks and everything. Now we can have the outlet size. Let's search for the outlet size. I think I'm skipping a couple of columns because of the time restrictions. Maybe you guys, when you're doing it, just do it for all the columns, so you guys will understand the better about the data, and you guys can apply the filter conditions. You guys can identify like issues like this one. Okay, different names. Okay, and you will be able to fix it. So once your the data is the plays most important role in the machine learning projects. So if your data is 100% correct, then the efficiency of the model will get increased. Okay, you'll get the proper results. And if you see here medium, oh, let me decrease the size here to 6. I think medium is fine. I think small outlets is a more and high are very less. Okay, depends upon the cities, right? And outlet location type and outlet type. Let me draw for outlet location type. Okay. Copying here outlet type. Let me search for outlet type. Okay, so data is getting messed up. Let's change it to 15. Okay, if you see here, supermarket type 1, supermarket type 2, grocery stores are there, and supermarket type 3 is also there. Okay, which are very less. Supermarket type 1 is our more number of repeated values. Okay, now let me check for the types. Yeah, outlet location type. Here I'm going to search. Okay, how many tier 1 and tier 2 tier 3 cities? Okay, I think here I can change it to 6 back. Okay, tier 1 is good and tier 3 is having more number of supermarkets, and tier 2 is little bit less and tier 1 is way less. Okay, a little bit fine, it is evenly distributed. So this is how you guys can do the data analysis by drawing the distributed charts for the numerical fields and count plots for the categorical columns. Now before moving on to the next step, here what I am going to do is I am going to correct this column wherever the values of low fat LF are there. So I am going to replace it with this actual values. Okay, let's do some data cleansing. Data of item fat content. Yes, this is item fat content dot value counts. Yeah, if you see here, these are the different columns. Now let's replace them. Okay, data dot replace of, going to replace which column? This is the column. Oops, okay, this is the column. I'm going to replace this column. Okay, with these values. Okay, first one is LF. LF I'm going to replace it as low fat. And next one is low fat in lowercase. Low fat, I'm going to replace it with this value. And what is the next value? Regular, reg, with the regular, right? Reg colon, it should be regular. Okay, and yeah, place, and in place is equals to true because I have to apply it on the original data set. In place is equals to true. Okay, now let's run this query. If you see here, LF and low fat has been added to the 5517 and regular has been added to the 3006. Okay, now we are done with the data analysis and data cleansing. Okay, now let me print the whole data. Data of head, first 5 rows. Oh, sorry, typo, it's not here, it's head. Okay, it's printing the data set for the first 5 records. Okay, these are the records. If you see here, low fat, regular, no missing values, looks good. Okay, now we have the data. So the next step is when we are feeding it to a model. Okay, when before feeding it to the data into the model, the first step that we have to do is how many category columns are there. If there are any categorical columns are there, we have to convert those categorical columns into the numerical values. Okay, here if you see here, item identifier and item fat content, item type, and like remaining total 7 columns, right? 7 out of 12 columns are categorical columns. We have to convert those categorical column values into the numerical values. Okay, if you see here, there are huge number of columns for the unique values for the count plot for the item type. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, but in real time it will be more. Okay, we cannot feed that dairy as 1, soft drink as 2, meat as 3. It will be impossible for us to do it. Okay, for that one, what we are going to do is we are going to use the label encoder, which is available in the sklearn. Okay, why we are converting this categorical column into the numerical columns is whenever the data is fed to the model, if it is a numerical columns, the model will be more efficient. Okay, it will find the more insights in the data. Okay, it will find the more connections inside the input features datasets so that it can predict the output dataset properly. Okay, now let's import that. Okay, import sklearn dot preprocessing. Sorry, instead of import from, it should be from sklearn preprocessing. Import, don't know, just typing label encoder. Label encoder. Okay, just importing it and creating an object for this label encoder. Okay, okay, not encode, it should be encoder. Okay, just creating it. Okay, now we have to apply it for the one column, item identifier. Okay, data of item identifier is equals to encoder dot fit underscore transform of this data of item identifier. We have total 7 columns, right? Let's repeat this step for the 7 columns. 2, 3, 4, 5, 6, 7. Okay, let's, okay, I made a mistake. It should be encoder, right? Encoder. So what we are doing is we are converting the categorical column values into the numerical columns with the help of the label encoder. Okay, now let's copy paste the column names of the categorical columns. Here item identifier, next one is item fat content. Okay, let's add the item fat content, and the next one is item type. Okay, item type. Okay, and what is the next one? Yeah, outlet identifier. And the next one is outlet size. Okay, outlet size. And what is the next one? Outlet location type. Okay, and outlet type. Okay, and to give you an example, okay, to explain you guys, if you see here how this label encoder works is, this item fat content is having 2 values, low fat and regular. What it does is, instead of low fat, it will change this low fat value into 1 and regular to 0, or vice versa. So that is what it is going to replace this categorical values with the 1s and 0s. Okay, that's what we are doing for the categorical columns. Now let me execute it. Okay, now it's done. Now let's check the values for the data content. Okay, dot value counts. If you see here, it converted to 0, low fat is converted to 0 and regular converted to 1. Okay, so this is how this label encoder works. So now what we have done is, we have done the data analysis completed. Now we have replace the categorical column values with the numerical values. Now our data set is ready. So once we have the data set is ready, what we have to do is, we have to divide the input datasets and output datasets. Once we divide the input dataset versus output dataset, then again we have to convert it into the training dataset and tested dataset. Okay, now what we have to do is, first we have to split the input datasets versus output datasets. So x is equals to data complete data frame drop columns is equals to, except the output column, which is the item outlet sales, remaining 11 columns goes to the input dataset, which is x. Okay, and what is y? Y is nothing but an output dataset, which is data of item outlet sales, the output column. Okay, item outlet sales. Okay, if you see here, the columns, 11 columns goes to the x, which are input columns, and y, which is outlet sales, which goes to the y. Okay, I'm just executing it. Let's see, x is having 11 columns now. Instead of 12 columns, it become 11 columns now. And y, which is an output column, okay, which is only 1 column, right? This is the 1 column. Okay, now we have splitted the data set into input data set and output data set. Now next what we are going to do is, we have to split the dataset into again input datasets into training dataset versus the test dataset. Okay, how we are going to do is we have to import one more functionality from the sklearn dot model selection import. There is a inbuilt functionality train test split. Okay, I'm going to import that, and here x train, that is training dataset for the x and test dataset for the input dataset, and train dataset for the output dataset and test dataset for the output dataset equals to train underscore test underscore split. We are converting input dataset output dataset where test, how much is the test size, is equals to 0.2. Here what we are doing is this test train split. Okay, this test train split, what exactly it works is it takes the input dataset and output dataset and test size as an input parameters, and it will give you the 4 output parameters values. Okay, the input set will be divided into the training dataset and test dataset, and wherever when we mention test size as 0.2, that means 20% of the dataset goes to the training dataset and 80% of the dataset goes to the training dataset. And here also same thing. Why is that? It is taking y as input, right? Again, y is against output dataset, y is nothing but an output dataset. Y is also being divided into the training dataset and test dataset. Okay, with the 80% as a training dataset and 20% as a test dataset. Okay, I'm just going to execute this one. Yeah. Now let's check it out. Okay, x dot shape and x underscore train dot shape and x underscore test dot shape. Okay. If you see here, our input dataset is having 8523 and 11 columns, and out of which 80%, which is 6818 data points, are becoming the train dataset and 11 columns, and remaining 1705 data points will become the test dataset for the input dataset. Okay, now let's check for the y, same case. Y and y. Okay, similarly here instead of 11 columns it will be only one column, 8523, that is the source dataset, and 681 columns are the train dataset and 1705 as the test dataset. Okay, now we have split the dataset into training dataset and test dataset. Now next thing is model creation, which is more important. Okay, model creation. Okay, here we are going to create a model. Let me convert it to text. Okay, model creation. So here we are going to create the model. So how we are going to create the model here is from Bost import Bost, XCV regressor. This is the gradient boost regression machine learning model which we are going to create. Okay, model is equals to XCV regressor. Okay, our model has been created. Oh, typo. Again typo. Okay, now our model has been created. Now let's train our model. Okay, training our model. Okay, how we are going to train our model is, let's take this model dot fit. We have to pass the two parameters, which is x underscore train, training dataset, and y underscore train. Okay, x underscore train will be having the input datasets and y underscore train will be having the output datasets for the same input set, and we are fitting our model with the dataset. So our model has been created now. Now let's evaluate our model, how it is performing. Okay, for that one we have to import one more functionality from the sklearn. Sklearn dot matrix import R2 underscore score. Yeah, R2 score has been imported. Okay, now score is equals to R2 underscore, and what we are going to do is we have to predict the values. Okay, predictions with the train dataset. Let's predict the values for the training dataset only from our model. Okay, here what we are doing is we have created a model called gradient boost regression machine learning model. So once we created the model, we are fitting that model with the training dataset of input dataset and output dataset. So our model has been created and our model has been trained here. So once our model has been trained, what I'm going to do is I'm going to evaluate our model training by predicting the values from our model. Okay, what are the predictions? So what kind of predictions we are making here is I'm going to predict the model dot predict the values for the same trained data set. So whatever the data set our model has been trained, I'm going to predict the values for the same data set only. Okay, x dot train. Let's see how our model is working. Okay, predictions training data set. So let's find out the score. R2 underscore score by passing the predictions underscore train comma y dataset, y underscore train. Okay, here it is the predicted value and here is the exact values, and here it is going to find out the how relevant these two values are. R2 square. Okay, R2 score. If you see here 83, so if you see here 83, that means a very good number. So the values ranges from 0 to 1. Okay, the value whatever which is near to 1, that means our model has been trained very well and it is working efficiently. And 83% of R2 score, in the sense our model is very good. Okay, no need to worry about that. Now what we had done, we have evaluated our model with the training data set. Okay, now we have to predict the test data set which is completely new to our model, and let's evaluate the score for our model. Okay, how we are going to predict the new values from our model. Okay, predictions for the test data set. Okay, let's predict the values. Model dot predict with the test data set, which is x underscore test, completely new data set for our model. And here our model has predicted the values for the new data set. Now let's find out the score. Okay, predictions underscore test data set, and I'm passing the y underscore test, which is the actual values. Okay, and I'm predicting our model evaluation. It is 0.27, which is really bad. I would say it's not so good, because only 27% of the time our model has been predicted the good values, and rest of the time it is not predicting properly. Okay, did we do anything wrong? I don't think we have done anything wrong. Predictions test model dot predict x underscore test, which is a completely new data set. We're running it and we're evaluating the R2 score for this 27.1, which is okay, fine. 27% of the times, which is nearest to 0. I think our model is not performing well. Maybe we can make some changes like removing some unique columns and all that stuff. When we make all those kind of changes, maybe our model score for the new data set might get increased. Okay, fine guys, this is how you guys going to create the Big Mart sales prediction machine learning model. So let me recap what we have done so far. Okay, don't worry guys, I'm going to share this Google Colab notebook link and given the input data set as well with you guys in the description box. Please do refer it over there. Okay, first what we are doing is we have created the input data set. We are reading the data set by using the pandas, and here we are printing the top 5 values from our data set, and here we are getting the information about our data set, and we are having the 7 categorical columns and 5 as the numeric values. Okay, and here we are finding any numerical value, any null values are there in our data set or what not, and we are able to find that 1463 numerical values of item weight column is having null values, and 2410 data points of outlet size categorical column is having the null values. So numerical columns values will be replaced with the mean, and categorical columns values will be replaced with the mode. Okay, now we are finding the average value of that particular numerical value, which is 12.85, and we have replaced it with the item weight column. Okay, once that is done, we just checked it out. I think we are able to replace the item weight column null values with the average values of the particular column. So hence we don't have any null values after that. Now what we are going to do for the categorical column, which is nothing but the outlet size. Okay, what we had done for the outlet size is we have created a pivot table for the outlet size column based upon the outlet type column. Okay, and we are able to find the most repeated values of the outlet size for based upon the outlet type column. Okay, and here we are able to find wherever that missing values are there. We have found those missing rows, data points, locations, and then here we have replaced those values with the mode value. Okay, and once this is done, we are able to replace that categorical and numerical values with the non-null values. Okay, now our data set is completely ready. Okay, after that we had just drawn some graphs for the distributed for the numerical fields and the count plots for the categorical columns. Now here we are able to find out this issue where that same column values will be repeated in different names and different terminologies. So we have been done the data cleansing on this item fat content column later. Okay, and we had done that. After doing that, so we are having 7 categorical columns, right? So before feeding it to the model, we have to convert this categorical column values into the numerical columns. So hence that we have used the label encoder from the sklearn preprocessing model. So we have fit that by using the fit transform for the 1 2 3 4 5 6 7 columns. So we had done it, and after that we are able to see that value, sample values for the item fat content. So low fat content has been replaced with a 0 value, and regular fat is replaced with a 1 value. Okay, so after doing that, we have split the dataset into input dataset and output dataset. X is having the 11 columns with the input dataset, and Y is nothing but a 1 column, which is nothing but the output column, which is item outlet sales. So once the splitting of input and output dataset gets completed, so we had splitted the dataset again into test dataset and training dataset by using the train test split. Okay, and 80% of the dataset gone to the training dataset and 20% has gone to the test dataset. And now we have created a gradient boosting regression machine learning model, and once we created the model, we fit the model with the training dataset of X train and Y train, and then we have evaluated our model with the R2 score, okay, from the sklearn matrix. So we have predicted the values for the training data set by using the predicting the values of the X train by passing the X train as an input to the model. Okay, and here we are able to predict the values of training data set. Here we found the similarity, percentage of similarity between the training predictions on the training data set versus the training data actual values. We are able to come close, almost 83%. It is working absolutely fine for the training data set, but when it comes to the testing data set predictions, I think it is performing way less. Actually 0.27, it's a bad number. Maybe we can do that model improvement by removing this item identifier, which is nothing but a unique identifier for the particular item, right, which is not going to make any sense, so that maybe our model score might get improved. Okay, so we can do all these kind of steps, okay, to improve our model performances. So that's it, guys. This is the Big Mart sales prediction machine learning model project, and if you like the content in this video, please do like and subscribe to our channel. Thank you so much. Thanks for watching this video.